Next up is Chris Perkins, Director of Lab IT and Operations at the Broad Institute. Chris helps Broad researchers manage the IT assets that acquire, store, and transfer laboratory data. Previously, Chris directed research systems for Flagship Pioneering and led global IT at Takeda for manufacturing and data, scientific data systems. He earned a BA in Information Technology from Boston College and an MBA from Worcester Polytechnic Institute. Today, Chris will be speaking about the first mile of lab data, operationalizing data flow in heterogeneous research environments. Over to you, Chris.
Thanks very much. Thanks, everybody. Appreciate you giving me some time to talk about what it is I do every day. We'll be talking about data flow in heterogeneous environments, and that is a substitute for a more colorful phrase that I would like to use, but we'll stick with heterogeneous at the moment. We'll talk a little bit about sort of the vision that I have for the labs at the Broad and sort of the stakes that we're all working on. And I'll start with an example about AlphaFold. Many of you are probably familiar with it. It does protein structure prediction, and it's been a huge success, came out of Google. And the reason why it was such a big success was partly the model and partly the people that helped develop it and the vision that they had, but also that the data sets that they worked with were really well structured, really well annotated, manually curated, with sort of massive data sets that were really, really, really well tuned. And I think that this sort of large interoperable data sets sort of set the standard and really the table stakes, I think, for how we can structure our data for artificial intelligence. This is sort of a North Star that we hold up for at the Broad of what we're trying to get towards. This, my thunder has been stolen. You'll see this slide over and over again, probably for the next 5 years. But really, what I talk about, this is the metadata. You can't just shove things in LLM and expect to have an AlphaFold come out of it. One of the things that we're trying to instill at the Broad in order to get there is sort of a culture of metadataism. And you could think of it as a religion or a cult, but really it has central tenets. And we think of these as akin to commandments. And one is that thou shalt capture metadata at each step of the workflow. Every time a plate comes out, you should be recording the barcode. Every time you perform an assay on a compound, you should be checking that against the registration system. And attaching that at experiment time and not afterwards, make sure that you don't lose that context when the data start moving around in ways that you don't expect them to. Thou shalt capture metadata using structured schemas. And I think that this is a really important one for us to be able to look across the diverse sorts of data sets at the Broad and being able to unify and have a structured ontology on the metadata is almost as or more important than the data itself. And this is really one that gets lost in translation a lot of times, is that shalt not enter metadata more than once. And I think that, especially in the dry lab, when there's different workflows and different consumers of the data, don't think about the burden that it places on the people at the bench. This is something I'll talk a little bit more throughout the talk. And that's something that we continually come back to, and I see, especially in an academic setting, that asking the researchers to do anything that isn't directly related to the success of their assay is asking really too much of them. So that's sort of the steps at the Broad and the vision that we have, and then it meets sort of the messy reality. And I'll go off a little bit here. I've been with the Broad only since August, and I spent the entirety of my career in industry before that. Most of my career at Takeda, some at Flagship Pioneering, a little bit at Biogen, and I'm used to CEOs setting mandates and telling you how it is. At the Broad, you can really think of it as a collection of fiefdoms, that there are individual labs that are set up. Anyone who is a tenure-track professor at Harvard or MIT can come set up shop at the Broad, and a lot of people do, as long as they bring their money with them. And that creates a really exciting place to do work. And you bump into places, and you go to talks, and you meet people from different disciplines, and a lot of exciting work has come out from that. As an IT professional, it is a nightmare. I will say that a highly heterogeneous environment. I was giving an example earlier that there's a lab at the Broad that runs their own network off of our guest network. And like these are the sorts of things that we're challenged with as IT professionals every day. There are no central ELN or LIMS mandates. There is no one LIMS for the Broad. Each lab is left to their own devices. Many have written their own. And I think that especially 25 years ago when no one else was doing this, it was really a requirement. Now you can sort of buy equivalent functionality or better off the shelf. And decentralized budgets. So the way that funding works, each lab brings their grants, brings their philanthropy, brings their funding sources with them, and as an IT professional, I can't tell them how to spend their money. I would say at least once a week, I get a request from someone in a lab who wants to buy a NAS full of solid state drives and stick it in their lab. And I can tell them no, and they're gonna turn around and cut a PO on their grant, and they're gonna run it off the network. So really, it's a matter of influence and how we can do that at the Broad, and that's what we're working on. So there's that, right? The organizational, it's academia. I tell people I joined the Broad because I wanted to be at a place where the scientists are in charge. And now I tell people, be careful what you wish for.
How's that working for you?
It's, so far so good. So we'll say, I think the Broad is probably most well known for the next-gen sequencing, the pioneering that they've done there. And I would say that the Broad clinical labs do an excellent job of acquiring the data, storing it. I'd say we probably manage something in the order of 80 petabytes between on-prem and cloud storage for our gene sequencing. That is a well-developed pipeline that they do very, very well. They do the same thing over and over and over and over again, and they've got it nailed down. What I'm most concerned about is the small little research lab that's a PI and 2 postdocs that is developing an instrument that is novel and that there are no data pipelines for. And I'd say, besides the bespoke instruments, these are the plate readers and the flow cytometers and sort of the low throughput data that because it is maybe an assay that only gets run every 2 weeks or maybe only on demand, that the data pipelines just don't exist and the scientists don't see the value in trying to create them because it might be throwaway work. So this is sort of the long tail, the reality of the data that I'm really worried about. I'm not a scientist, I'm an engineer by training, but for me, these are the critical assays that sort of make the difference between whether a project goes forward or not. So capturing the data in a structured way, I think is really important. Why SneakerNet doesn't die. And I think that this is a conversation I have, so at least once a week someone asks me for a NAS, once every day someone asks me for a USB drive. I'm running an assay next door at the Whitehead and the instrument's not connected to the network. Or our lab network is configured almost like an OT network in that access is denied by default and everything that's allowed at the firewall is an exception. And this is excellent. Our security chief sleeps very well at night. And our scientists have a really hard time, and this is why they sort of route around us. If you're working with an external collaborator, you're working with a new cloud provider, the turnaround time on our access controls for the firewall is just too slow for our scientists, and they're going to go around us. So there's a perception of safety. I've had a lot of researchers tell me, well, it's in my USB drive. I know where it is. One time in grad school, they lost my data in IT, and this is how I'm going to maintain control. And simplicity. And I think a lot of times, user experience came up in terms of adoption here, and I think that is still true to this day, that a lot of the systems that we ask our researchers to use, especially at the bench, require you to log in 3 times and check your phone, and then you have to click through 7 things to get to your data. It becomes too much of a burden, and researchers don't want to do it. I had a lab manager tell me one time with a straight face that she will only do the path of least resistance, and it drove me nuts for a long time. But then I realized that it's my job as an IT service provider to really work within those constraints. I say academics also chronically underinvest in the hardware in the labs. I've been in industry 20 years, and I think twice I've seen like a bad fan on a lab computer. I've seen it twice last week. I've seen hardware cables get pinched. I've seen computers that just the spinning hard drives just stop spinning. So it is a reality of the work that we do here that the researchers look at their budget and just choose not to allocate towards any sort of technology refresh. As long as the computer still works, if the computer gets decommissioned, they will shove it in a closet or under their bench rather than return it to IT because they would like to reuse their hardware later. We do see a fair amount of vendor lock-in. This is not unique to academia. You'll also see this in industry. But this instrument costs $2 million to replace, and the software that drives it only runs on Windows 10, and that's the way it's going to be, and we're not going to upgrade it. It sort of alluded to this earlier, there's sort of the security versus science standoff, that the reviews that are required by our security team take so long that the scientists are just going to go around us. And I think that the IT mind goes immediately to control and centralization, and I think that in order to help the researchers do their work, that we really need to pivot in that how we think about that. So I'll talk a little bit about sort of some of the other friction that we see and costs in the lab today when it comes to getting data out of the lab and into the computational space. And this is something that my former colleagues at Flagship may find interesting, that there's a AWS technology called File Storage Gateway. It presents S3 storage as a POSIX file system. Poorly, but it does it, and you're able to sort of access cloud storage and get data into S3 where you can run sort of your data pipelines on it in a drag and drop manner from the lab. GCP does not have a competing product. So anytime that we're getting data off of the lab instrument into our GCP storage, we're using a CLI, we're asking a researcher to do a G-Cloud login, or maybe we're downloading a FileZilla type client to their machine in order to get it onto GCP. I think this is really a gateway problem for our researchers. How do they access cloud storage from a Windows desktop? And it's just not intuitive, and it's not easy. And a lot of the vendor-provided systems that we have just don't have a native functionality, whether that's by design or not. I'll leave that to the vendors to answer. But I really believe that this is a huge gap in getting that sort of long-tail, low-throughput assay data into the computational space. I think something else that we often hear from the researchers is cost, and that we can quote them, or it only costs you pennies per gigabyte to store your data in the cloud, and then they say, well, one of my research associates last week ran a rename on things in the Google bucket, and I got an $11,000 bill. And that's something that it happens once, and then everyone hears about it, and then no one trusts it anymore. And so we've had to do a lot of work rebuilding trust in our cloud storage. And I think that data egress also really scares a lot of researchers away. What if I want to reanalyze my data? Is it going to cost me $10,000 to re-download it? I don't want to have to. I could buy a NAS for $10,000 and store my data for all of time. And the researchers make that decision 10 times out of 10. They will choose to have local control over, rather than having to pay to get their data out. I mean, there's a school of thought that says that cloud storage is like a self-induced ransomware, right? You're locking your data up and you're paying to have to get it out. And I think that before the AI transformation, the sort of on-prem to cloud was the biggest disruption that we've seen in our industry. And I don't think that those costs, that this change is fully permeated, especially into the academic space. There's also sort of a problem with metadata, and I've heard wet lab scientists refer to computational folks as sort of data parasites. Well, I generate all the data, they get all the glory. And I think that a lot of times that we think about, I had a researcher tell me, a computational data scientist told me, I only need 20 pieces of data, metadata to process my data pipeline. And I'm imagining the researcher in the wet lab with a pipette in one hand and a plate in the other, and the alarm going off, from the freezer behind them. And I'm thinking, if I can ask them to enter 20 pieces of metadata, you're going to get a pipette straight in the eye. And especially if you were going to ask them to enter it more than once as you move through the data pipeline. So I think that is really a system gap. And I know it exists in industry, but I think it's just even more prevalent today in academia, and especially in those long tail assays. When we start to think about what is the cost of this, that we have, inconsistent acquisition systems really hinder data reuse. And I hear anecdotally all the time, why is someone running at Western when we already did it, down the hall? Or why is someone running a screening assay on this compound when this other department has already done it? And it just happens constantly at the Broad. I'd say hoarding low-value data inflates the storage costs. We heard someone earlier say, they don't want to ever get rid of their data, and we see that every day. I think, like I said, we have 80 petabytes between on-prem and cloud, and I think if you were to ask researchers how much of that is useful, it would be single-digit percentage. And so we pay, millions of dollars per year to store this data that will probably never be used again. I think, Savanda was talking earlier about, high-quality data, and that sounds counterintuitive, that more seems better, but really less is more, I think, when it comes to this. And then, poor documentation and duplicated effort and data archaeology. And I think Bro suffers this more than people in industry, especially because the postdocs just come through on a 1 or 2 year appointment, and then they leave, and then they want to progress the project, and they're calling someone up, or they're emailing them at CERN, or they're trying to figure out where people have gone, and the data just either get lost, or it takes a lot of time to drag it out of the systems. So now that I've whined about all of my problems, I can start to talk about what are we doing to try to solve it. And there's really sort of two phases. There's a tactical and there's a more strategic for the Broad today. And I think about sort of the phase one is meeting the users where they are. And I joined the Broad, and one of the first things I asked was to get a list of all the instruments in the labs, and there is no list. And I said, well, all right, well, I'll just go make it. I'll do an inventory, and I'll walk through the labs, and people would stop me from entering their labs. They say, oh, you're from IT. We have stuff in here that maybe is not approved, and I'm afraid you're going to take it away. And so like that's the challenge that I was not expecting, Margaret, when I joined the Broad, was to be sort of viewed as a hostile invader into their lab space. So really, the way that I'm trying to solve it and encourage my team to solve it is to meet the users where they are. And that our job is to help the users, help the scientists, and our job, in many ways, is to protect them from IT and their standards and policies that we have so that they can get the science done. Don't tell my boss I said that. So probably one of the first things that we do to meet the users where they are is sort of we call it a mule architecture, maybe a jump box, but really it would be finding one of those ancient Windows 7 machines in the labs and putting a modern control machine in front of it. This is not new, but I think it is comfortable for users to be able to see, here's one computer, this is the one that's going to get the data off. And then we can have a data pipeline that comes from the Windows 7 machine into a supported machine, and then we can grant that access to our internal storage and to our cloud storage. I would say this is, the pushback that I get from the users on this is, well, now I have to buy another computer, I have to spend $1,000 for this, and I can tell you, well, it's either that or you don't get your data. And generally the checks start to come out at that point. Strategy two is sort of try to mimic what a USB drive does by creating a data pipeline. If you drag your data into this folder, I will have a PowerShell script that copies it to G-Cloud in the background. You don't even see it. This is suboptimal in many cases because now there's someone on my team whose job it is to maintain these PowerShell scripts, but at least the data are not walking around in their lab on USB drives, and it just sort of gets us a step forward to where we need to be. I think the third thing we do is sort of financial transparency. This is where my MBA comes into play, where I can show users sort of amortized cost over 3 years. Okay, you're going to buy a NAS once. Over 3 years, the cost of maintaining that, and when you fill it up, having to buy another one, as opposed to subscribing to a G-Cloud. This is difficult because I think cloud providers make this sort of intentionally obfuscated, and that they're really good at showing the per month storage cost, and they're not good about showing the data egress and exfiltration costs. And that's, again, it's what scares the users and takes some amount of work with finance to present sort of a total picture to them, what it would take over the year. I'd say we've been moderately successful in this, and it's something that we really hope to work with our vendor providers to have a better solution here. So that's sort of phase one, meet the users where they are. When they submit the ticket, show up. And I think that's one of the best things we can do to earn trust is to be in the lab, side by side with them, working. It builds trust. It also shows, it gives me an opportunity to learn what the researchers are doing and what their workflow looks like. I still take tickets for my team, mostly because we're small and I don't have a choice. But also it really puts me close to the action. That's really one of the reasons I enjoy the Broad so much. Step 2 is sort of looking at an automated future, and how do I get to that place where I have well-annotated structured metadata associated with our data so that we can start applying AI models to it. And the Broad can think about this in a number of ways beyond just making data more accessible within the Broad, but being able to think about data as an asset for the institution so that when we do partner with some of the bigger companies in here, we can start to look across our labs and not just within one particular lab. And I think probably the first one is to come up with a Broad-wide ELN and LIM standard. When I talk about this, at Takeda, when I left, Savannah, correct me, there was something like 9 ELNs. And I know that number has dwindled because someone in leadership said that this is crazy. We need to get on a unified standard. Today, there is no one at the Broad yet who has been willing to say, we're ready to make this commitment. And that's part of my job, is convincing the Broad that really it's in our best interest to do it. And I think about creating a standard, and because I don't have a stick with which to beat these labs, I have to have a really big carrot. And our aim is to create sort of fear of missing out, that we want to build really exceptional workflow and pipelines for the users so that they see it and they want to buy into it, as opposed to us telling them you have to do it. Obviously we'd have an API integration. These next 2 bullets caused a whole lot of discussion. And if I had presented this talk 5 years ago, I would have used different language. We talk about a structured ontology, everyone's speaking a language. And I think that that's different than what you'll hear most people that say, okay, we need to unify an ontology, we need to call a stroke, a schemic stroke, and we need to have everything sort of aligned. And I don't think that our scientists at the Broad are ready to do it. Large language models sort of give us an opportunity that maybe we can abstract that away. And maybe we don't have to have everybody on the same ontology, but if we can use an LLM to create a mapping ontology, we can let users sort of use the vocabulary they're used to, and we don't have to enforce a standard on that. Similarly, this bullet, as written, said it was an extensible schema where we would create schemas for data capture that would have a certain number of minimum required columns, and that you could sort of extend upon that. And I think that gets immediate pushback when I talk about it at the Broad. My data model will never fit. This is novel science. You can't tell me what to do. I get that a lot. But really just having a structure that we can sort of derive insights from is better than having no structure at all. And we have a lot of labs say, well, I use an ELN. I write my things down in my paper on glass notebook, and I'm doing a really good job. And we have to say, well, that's just not even the start of it. You really need to be capturing your data in sort of structured results tables and having a predictable output so that we can then sort of build models on top of it. And I'd say, for as many different labs we have at the Broad, we have almost as many different solutions for solving this today. Some have built really sophisticated systems in Google Sheets with VLOOKUPs across sheets. We have a lab that essentially wrote their own chromatography data management system because they weren't satisfied with what was available on the market. And so we have to work with those users to be able to connect those systems together. And it's not a monolith. Sort of the second strategy, and this is something that I think Benchling has done a really good thing with, which I was honestly a skeptic of this product when it was first introduced, but the more I think about it, the more I think it really could benefit, especially users at the Broad, is associating that metadata with the data at ingestion, when it's acquired, having a connection to the instrument at the API layer, or at least a binary file watcher, to be able to take that out of the RA's hands, because their 2 hands are already busy, and be able to have that ingestion and that association happen right at the assay. And I think that that's something that, of course, for the high throughput, this has been a solved problem, but for the low throughput assays, it really is still a huge problem for us. And I think that the third thing that we worry about is sort of downstream. And I talk about the first mile of informatics being sort of lab IT, and this is really the last mile. But data delivery is something that constantly comes up at the Broad. We have a series of core labs. And data delivery usually happens either via USB drive, or maybe if we're lucky, it's an upload with a sample sheet to a shared file drive. How do I get 500 gigabytes of data delivered to these users and know how much to bill them. So having Broad has partnered with a company called Manifold and has started to look at data delivery using their platform. And not just the data delivery, but be able to kick off a Nextflow pipeline or a FlowJo pipeline or something. As the data are ingested, it lands in the cloud, and Manifold picks it up at that point, runs the analysis. And so that, when I close my eyes at night and I think about the lab that I want, it's one where the operator walks up to the instrument, starts the run, and walks back to their desk, and the data are there. We're not close to that today, and we're trying to be able to get in a position where we can get the Broad to invest to build these systems to help our researchers. That's my talk. I want to make sure I acknowledge Jen Nava, who's the CIO, has provided a lot of leadership here at the Broad on this. Noam Shoris, who directs computational biology for the epigenomics group, and my team, Yair and Phil, on the ground every day in the labs, making this happen for the researchers. Thanks.
Questions?
Yeah. Hi, thank you for your talk. That was lovely. My husband worked at the Broad many years before your time, and one day one of the professors sent out an email to the entire organization saying, I would really appreciate it if you guys would do a better job wiping your feet off when you come into the building, because I like to walk around barefoot, and it's really gritty under my feet. And so that's the sort of thing you're dealing with all the time, and academia is definitely worse than industry, but I think all of us in research have an element of that, where it's like, you can't tell me what to do, and you're getting in the way of my creativity, and I'm just trying to invent things, and this isn't a GXP lab, and leave me alone. And I think it's really hard for us to prove to them that there are benefits if they would play nicely with others. And so it's more of a comment than a question. I really enjoyed your talk. Good luck, Godspeed.
I appreciate it.
Well, I'll turn that into a question, because that was exactly my question. So talking about practical ways to build that incremental trust when you don't have decision authority, which you don't, right? You need to do everything by influence. So give us some practical tidbits of what you've seen has worked.
Yeah, so it sort of alluded to it. I think being shoulder to shoulder with people in the lab can help build sort of credibility. I think the approach that we're taking in sort of try to build a data platform standard is pilot. Pick a group, they've got a well-defined workflow. Can we port this into a commercial tool? Can we make it work? Something like Benchling, and if we can show that and we talk about it and we present, one of the great things about the Broad is there's no shortage of opportunities to tell people about your work. There's lots of ways to communicate about what you're working on, and that's one of the things that we want to take advantage of during the pilot, is not just go away for 6 months and build something, but sort of bring people along with us as we do it.
Oh, gosh. All right. So I guess my question was, how much collaboration between the different labs that do different work do they collaborate, and how does that determine your decision whether having like a universal, broad universal, like one ELN, let's say Benchling, makes sense to bring in? Like, where do you find that balance?
Yeah, and I think if I were to contrast this with my experience at Flagship, the labs work together all the time. And especially they take advantage of the core labs. So the genetic platform, the Broad Clinical Labs, is out in Burlington. And so if you want to have samples run and sequenced, you submit them, and all the labs take advantage of it. And all of them get the data back totally devoid of any metadata that was associated with it before, because it's been run in a different system, and then it comes out. They know who submitted it and when, but they don't know what program it's for. They don't know what asset it's to. So to me, that's one of the biggest opportunities we have at the Broad, is to be able to simplify that workflow. I mean, I sat with our Broad Technical Services team where we call it walk-up sequencing, where you walk up to a deli freezer and you drop off your samples and you enter them. And when the staff picks it up, they log into 5 different systems during their day to sort of process this. And the ability to reduce the amount of clicking that needs to be done and also simplify that sort of data exchange is really a big opportunity for us.
Thank you, Chris. Very useful to get to know, firsthand what's going on intramurally. So my question is, you joined recently, and given what you described, that Broad is an ecosystem with a lot of silos, I think, when it comes to actual research. Do those labs also have people, IT people, that would compete kind of for their, IT things?
They do. I'd say less traditional IT and more the sort of the informatics side. But yes, and it's definitely, I'm in a situation where I have to tell an MIT grad student they don't know as much about the network as they think they do. And that can become a difficult conversation. Yeah.
Any other questions?
Yeah. More like a comment. I mean, I led a big digital transformation program elsewhere, a very large organization, and there was a lot of convincing of scientists as well. Just because you're in industry doesn't mean like, oh, you have the funding, you're leading this big effort that the scientists really buy in. So I love that you said, oh, you had to create that formula that they were missing out, and oftentimes, at least being in technology and being on the IT side, you do have to do that. You have to, this is how it applies to you, right? So maybe some things that, like strategies, in terms of creating that formula, what did you have to do?
Yeah. We haven't done it yet. I'd say in industry. Yeah. I mean, industry, at the end of the day, if you don't renew the license for a system, the users aren't going to be able to use it, right? If we don't renew a license, they're going to go out and buy their own. I think that's sort of the key difference. I'd say, yeah, it's sort of different flavors of the same problem, just the consequences are perhaps more dire in academia.
I love the metadataism culture. I think I'm going to use that to explain, because when we speak about metadata to scientists, they just shut off. It's a lot on them. So my question is, when you speak about structured flexibility and capturing these metadata elements, who is making the decision on what is the necessary metadata for that workflow? Is that going back to the scientists, or is that someone in the consumption side?
Yeah, I'd say when it comes to defining what metadata is required, that's really a dry lab function. And they're going to say, I need to know sort of the parameters, the date capture, the program, those sorts of things. And then it becomes a negotiation with the wet lab today, what they can provide. And my goal is to automate as much of that as possible.
Okay, Chris, thank you.